Yeah.
Okay. So, today what we will learn is basically oxidizing agent and reducing agent. Okay. So what are oxidizing agents? Oxidizing agents are those compounds which can oxidize others and reduce itself. So oxidizing agent will be which oxidizes others and reduces itself. Okay, during the chemical reactions. Okay, so those reagents in which oxidation number decreases or which undergoes gain of electrons, then it is called a redox reaction. Okay, and these are termed as oxidants. So what are the examples of oxidants? You can say KMNO4. This is one. Second is K2Cr2O7. Third is HNO3. These are all oxidizing agents. Examples of oxidizing agent. One mark question. Give two oxidizing agents. Name two oxidizing agents. You should be knowing this.
What's the second one?
K2Cr2O7.
K2. Okay.
Okay. So now, before I start on with your, redox and everything, what I will do is I will bifurcate oxidation and reduction, and then I will give you all the details more nicely. So have you written the definition of oxidizing agent?
Yeah.
Okay, I'll repeat it once again for you. Oxidizing agents are those compounds which can oxidize others, and reduce itself during the chemical reactions. Okay, these reagents in which for an element oxidation number decreases or which undergoes gain of electrons in a redox reaction. Same way, if I have to write it for reducing agent, what will I write? Reducing agents are those compounds which can reduce others. They will reduce others and oxidize itself. Itself during the chemical reactions. Okay, so these reagents in which oxidation number is increasing or which undergoes loss of electrons, those are known as reductants. Reductants. Basically, examples if you talk about Ki, Na2S2O3. Okay, so these are the two things. Okay, so actual redox starts from here, Swapnam. Like whatever we've done till now, we were actually understanding. Now you will see both the things, redox, reduction and oxidation taking place in one equation itself. Okay, so have you written this? Shall I move forward?
Okay. I still didn't write it.
So I'll repeat it once again for you. Reducing agents are those compounds which can reduce others and oxidize itself during the chemical reaction. Okay, shall I move forward?
Yeah, does that one say Ki down the
Yes,
bottom?
Ki, and next one is Na2S2O3.
Okay, yeah.
Okay.
Yeah.
So let us understand this into the details. Okay. So what will I do? I will write here oxidation, and here I will write reduction. So what I said, oxidation is
Oxidation
loss.
is oxidizing others and reducing itself.
Correct. So loss of electrons. This will be gain of electrons. Okay. This will be gain of oxygen. This will be gain of hydrogen. This will be loss of hydrogen. This will be loss of oxygen. Okay. Now, if I have to say example of it, see, a to the power 0 will, what I said, loss of electron. So electron will be lost, plus a will become positively charged. That means what happened? The oxidation number increased. How it increased? From 0, it became +1. From 0 to it became +1. Oxidation number increased.
Okay, so
Okay, one more example I will show, then we will discuss this once again. In this, reverse will happen. What I said, gain of electron. So see, plus gain of electron will give you what?
lower oxidation number.
Minus.
Yeah.
Reduction.
Yeah.
By reduction, the oxidation number is decreasing.
Yeah.
See,
decrease. Yeah.
from zero it became negative. Oxidation number is becoming from 0 to -1. Oxidation number is decreasing. Is decreasing. That is reduction. Okay. Now ask me if you have any doubt.
No, I don't have any doubt.
Sure?
Yeah.
Because now we will be doing
Wait,
very important.
let me just write down the gain of O2 part.
Please. Please do that.
Okay, so okay, I'm done. I'm done.
Okay. So shall I move now?
Yeah.
Okay. So now, Swapniv, you have understood like how the oxidation number is increasing, decreasing, which reaction is called reduction, which is called oxidation. Now we will see an actual redox reaction where both the processes are happening. Okay.
Yeah.
So let us start with the first example. The example is Zn plus Cu will give you Zn plus Cu. So you will say, okay, what is so difficult here? Okay. Now let us see what is happening here. Zn, there is no charge. This is plus 2. Okay. What happens? This will lose the electron. Correct? Which will lose the electron? This one. Why? Because see, plus 2 to 0. It is becoming plus 2 to 0. That means oxidation number. Okay, is it visible?
Wait. Okay, yeah, now it's visible.
Yeah.
Okay, so Zn plus Cu.
Wait.
It's loading again.
Okay.
Yeah.
See. This is becoming from plus 2 to 0. This will be what? Oxidation number is reducing.
Reducing, yeah.
That
So
means
it's
this
reduction.
is a
Reduction.
super. In this case, what will happen? This is 0 and this is becoming plus 2. Correct?
Yeah.
That means oxidation number is increasing.
Increasing, yeah.
That means this is an
oxidation.
So this whole is a redox reaction. Why? Because oxidation and reduction is happening in the same equation. And we need the charges should be equal on both the side. Here also it is plus 2. Here also it is plus 2. It should always be equal. The charges on the left hand side and the charges on the right hand side should be equal. That is why it is called a redox reaction. So initially when we used to balance our chemical equation, what we used to do? Molecules, this, that we used to do. Now this time you have to balance the charges because you are checking which is giving electron, which is gaining electron. Like that. Okay, or doubt?
Wait, can you just say the last part again?
Okay. The last part is, I'm saying, like when we initially used to balance, you remember? We used to say, okay, Na plus H, it has to be NaH. But if it is 2, so you used to balance this and then write it.
Yeah.
So here we are doing what? We are balancing the molecular structure, right? Here what is being balanced? Charges. Why?
Charges, yeah.
Because see 0 plus 2 and 0 plus 2. So both sides the charges should be equal. You should remember because what happens in reduction and oxidation if this side plus 5, this side plus 2, no. Both should be equal. Correct? Because in exams questions come. Balance the chemical reaction.
Yeah.
Correct?
Yeah.
Okay. So have you written this?
Which part? Just the whole thing.
Yes, please write this equation because now we will be doing many such examples which will come. Like 1 or 2 questions, you will find it everywhere.
Okay, I'm done.
Okay. All right, let's do another example. Question number 2. Question number 2. The question is Cr2O7 plus Fe will give you Cr plus Fe. Yes, dear.
Mm-hmm. O7 to Cr plus Fe. Okay. So, what happens to oxygen?
Yes, you have to tell me which is reducing, which is oxidizing, which is the oxidation one, which is the reduction one. You have to tell me the charges. Charges at chromium, charges at Fe, Fe on left hand side, Fe on right hand side, that way.
Okay. What is the charge of oxygen? Is it plus? Okay. Look at this.
Okay.
Okay, so I think the
Yeah.
CR is oxidizing. And
CR
Fe
is
is
oxidized.
reducing.
Okay. How? How
Uh,
oxidation?
it's just a guess because
No, now you have to apply all those rules, which is reducing. So first you have to give the charges. No
okay.
guess.
Okay.
No, no,
Yeah.
Swapnil, no guesses.
But you didn't let me explain any.
Okay.
Okay.
So I'll tell
Okay.
you how to do this. Okay, don't worry.
Okay.
Do so.
Yeah.
Okay, so first to know the charge on this one, Cr2O7, we will apply the same logic which we were using. What was that? 2x minus 14 equal to 0. So x will come as 6. Correct?
Yes.
Yes? Yes or no?
Yeah.
That's what we were doing. Correct? 2
Yeah.
into 1 and then minus 2. So this way. So that means chromium is plus 6 and oxygen is minus 2. Correct? So you now you know, okay, there's a charge of plus 6 on chromium and minus 2 on oxygen. Correct?
Yeah.
Okay. Now, chromium generally, the charge is like this, plus 3. Okay. So, what is happening? From plus 6 to plus 3. What is happening? It is
Reducing.
reducing. So, that means the oxidation number decreases. That means it is the reduction reaction. Okay.
Yeah.
Now let's talk about Fe. Now what is the condition? We have to balance the charges also. Correct? So what we will do is I'll change the pen for this one. This will be plus 2 and this will be plus 3. Why? Because you know iron can take ferrous, ferric, plus 2, plus 3, both the states, correct? Secondly, if you see here, plus 2 minus 2 will cancel and only plus 6 will remain. Here 3 plus 3, 6. Otherwise, you could have written it this way also, na? You could have written it this way. Okay. How do I know that I will write plus 3 only here? I can write here I can write here plus 2 and then, sorry, plus 3 and plus 2 here. Then in that case, Swapne, what will happen? It will not balance. See, 6 plus 3, 9, 9 minus 2, 7 on left hand side and 5 on right hand side. So this will not balance. Plus, obviously, oxidation has already happened in chromium. So again, you cannot reduce. Now this time it has to increase. Correct? So that's how you check which one to write on which side. Okay? So now you will say, okay, plus 2 and this will be plus 3. So what is happening in this case? The oxidation number is increasing. That means it is the oxidation. Yes? And do you see the charge on the left hand side? How much it is? 6 plus 2 minus 2. So this and this gets cancelled. You have 6. On the right hand side, 3 plus 3, 6. So yes, charges are balanced.
Yeah.
Correct or no? Yes? Are you sure?
Yeah. Wait, why for the CR when you're calculating it, 2x minus 14, why is it 6?
I did this. We did this. What we were doing, we were learning this thing only, oxidation, how to take out the oxidation state of Cr in Cr2O7. Why Cr only? Because oxygen, you already know it is minus 2. So 7 into 2 is minus 14. This you don't know. So you said x. So 2 into x minus 14. X came 6, which I have written here.
But why is it not 7?
Oxidation state maximum is 6 only. Why it is not 7? It can't be 7, no? Like these all classes, what we were learning, we were trying to learn how to take out oxidation number for this reason, for these reasons. Otherwise, chromium belongs to which group? Tell me.
Which was it? Chromium was, I think it was in was it group 6?
Yes, it's in group 6. Correct? And the atomic number for this is 24. So how do you do it? You remember that atomic configuration, we used to write 1s2 and 2s2 like that. You remember?
No.
Oh, you haven't learned those. Electronic configuration of chromium.
No, I don't think so.
Okay.
Not sure. Are you talking about SPDF? That's what
yeah. 1s2. You remember 2s2? We used to.
Oh,
yes.
Okay. Yeah, I
So if we go by that, no, it comes plus 3. That's why we have written like this. And here we didn't knew what is it. So we took out like this. We took out like this 6. And why not 7? Obviously not 7 because we don't know. Like whatever we have learned in the last 2 classes, we were trying to take out the oxidation numbers only, no? When I was telling you, okay, take it out for pH3 because I don't know what is the state. PCl5, I don't know what is the state of phosphorus. Correct? So first I have taken out the oxidation number, or you can say the oxidation state. Then we saw, okay, this is reducing. And if one is reducing, so the second one has to obviously increase. Then only oxidation and reduction will happen. So that is the reason we didn't took plus 3 here and plus 2 here. We took plus 2 and plus 3. Correct?
Alright. Let me just see that again. Wait, can you just say that again? Like the plus 2 plus 3 part?
Yeah. Let's do this once again. Okay. See, we will say Cr2O7 plus Fe will give you Cr plus Fe. Okay. So now you know that iron can exhibit +2 +3, or it can be +3 +2. You don't know. Okay.
Yeah.
It can be anyways. So first, to remove the confusion, iron we already know. What we will start off with chromium. So chromium, you know, it comes +3. If you take only chromium, like if you take only oxygen, it will be -2. Only hydrogen, +1. Only aluminium, +3. So single, you know. Okay, chromium exhibits +3 state. This you know. But you don't know what is the state in this formula. When it combines in this form, then what is the oxidation state? You don't know. So you found out. How did you found out? 2x minus 14 equal to 0. So it will be x will be equal to 14 and x will be equal to this thing. Correct? Yes?
Yeah.
Wait. Something we are doing. Sorry. One thing we did wrong over here is like this. Correct? So then it will come 12 by 2, which is equal to 6. Correct?
Yeah.
Which I will write it here.
Yeah.
Okay. Then I will take this as -2.
Wait, why did x have -2 again? Like the first part?
This one?
No, above, like x -2.
This x
like,
-2.
well, like, yeah, both of them. Like, why is there
because
-2?
x, this you don't know, and oxygen is -2. That's what we are saying.
Okay.
Correct. And why am I taking total equal to -2? Because okay, I'll make it more clear. Give me some other pen. Okay. See, this is like this, Cr2O7. So you said this is +6, this is -2. But this whole is -2. Why? Because Fe is +2. Correct? So that is the reason I have written 2x minus 14 equal to -2. Because this which we are doing, see, 2x, 2 into x will be 2x, 7 into 2 is 14, and this whole is equal to -2. So this becomes x equal to -12, which will be equal, sorry, +12, and 12 by 2, which is equal to 6. So then I got these charges. So if this whole is -2, so this will be +2.
Wait. Okay, so this is -2 because Fe is +2.
No, it is not because Fe is +2. See, whenever you are balancing, suppose you are balancing H and Cl. So what do? You cross multiply, no? That H plus Cl minus. So what happens? This multiplies here and this multiplies here, and then they combine. Correct? That is what we are doing. This whole is -2 and this is +2.
Wait, what? You just cut out.
Okay.
You just cut out. Okay. Right.
Okay. Don't worry. Let's do it first, one by one. See, Swapnev, actually what is happening is there are two things happening over here. One thing is कि we are taking out charges for individual ones, correct? The individual ones, this and this, plus this whole, plus this whole is also being balanced with this one. Why? Because when you write H plus Cl, when it gives HCl, so how it gives? Plus, minus, +1, -1, and then when these two combine, when they are all together, so this +1 and -1 gets cancelled. So that is what is happening here. Cr2O7 is what? -2, and this Fe is +2. So these and these gets cancelled. So what I did, I have splitted these two. I have written it like this. Like this. So obviously the charge for this will go, see, this way. And the charge for this will go this way. So what I have done, I have written this whole thing separately. That is why this is like this. Now, why are we equating? Because we want X. I don't know the charge of the chromium. So I will write 2x minus 14. Why minus 14? Because oxygen charge I know. That is -2. So 7 into 2. Which will be equal to -2. Why? Because this is inside the equation. Inside this equation. And that's why these two are being equated to -2. So 2x minus 2 plus 14, which will give you 12, which will give you x equal to 6. So that's how I got the charge of chromium as 6.
But why is it -2 in the first place?
Here. This one.
Yeah, no, like the brackets?
Yeah, because this is all together, na? See, H plus Cl. So which is making HCl. So this is actually full combined thing, full.
Now and it's neutral when it's combined, but when you separate it.
So when it is separated, the charges will be there, no? The charge on this and the charge on this. So that's the reason this whole is equated to this one.
Yeah. And the charge of this happens to be -2.
Yes.
But like,
and
how do you
that's why
know
you
that?
were asking, na, ki ma'am, why not 7? Like you should equate it to 0. We were equating it to 0 because we were taking only this. If I ask you, okay, Swapna, take out the charge on only this, then you will equate it to 0. But here it is in combination with Fe. Or suppose instead of Fe, if I take it like this, let's change the question. Okay, for your this thing we are doing this. Instead of this.
Wait, before that, can I ask you a question?
Yes.
When you separate them, how do you know it will be -2 and +2?
Okay, so see, when you are taking this iron content, okay, so iron is what? +2. So that way we are taking.
Okay, so you're assuming iron is +2.
Yes. See, if I take aluminium, you know, universal charge will be +3. So this time, if this is aluminium, I will take +3. This will become -3. Then you will equate it to
equals -3.
yes. If you are, suppose you change the place over here, like fourth element, I don't remember as such. Maybe chalo nitrogen +5. Suppose instead of aluminium, if I take here, say N, you know nitrogen is +5. Then this will be equated to -5. Whatever in combination you are using with. Here it was iron. That is why we took plus or -2. If it is nitrogen, it will become this way. If it is aluminium, it will go. See, if here it is +5, it will be -5. If here it is +3, it will become -3. If here it is +2, it will become -.
With the iron, you said it can be +3 or +2.
Yes.
So how would you know then?
Okay, so that is what we have to think. Now you are saying ki how we will think is because here you know the charge. Correct? This you don't know the charge. +2 or +3. So you will have to check. When you will apply +3 here, the equation won't be balanced. So this comes with practice. This comes with practice. You have to think and then apply. So this is little
what do you
tricky.
mean balanced?
Huh?
No, I get what you mean by balanced. I'm just asking, like, how would you know if it's balanced or not? Because you haven't found the charges of the other one without
Okay.
finding
What
iron,
we
and
will
then
do
like
is,
so on.
we will do it with the other way. Like you said, ki, okay, let's take +3 and then do it. Okay. Let's do it this way. Cr2O7 plus Fe Cr plus Fe. Now this time I am assuming it is +3. So the equation will become 2x minus 14 minus 3. Because this is +3, so this will become -3, correct? That's what your question is. 2x will be -3 plus 14. This will be how much? 14
11.
minus 3 is 11. X is this
2.
much? 11 by 2. So what did you got?
11/2.
And you know, when you get this kind of a situation, you will have to draw the what? What is this called?
Wait, what?
When you have it in the what do you say? Fraction form. Then what it is called? It is called average oxidation state or number. So do you want your equation to be in this state?
No.
No. So obviously you will say, okay, 3 I did, but 3 I'm getting x as 11 by 2. That means it is wrong. So then what will you do? Again, you will go here and this time you will think iron as
2.
+2 and this will be -2. This whole I'm talking about. Okay.
So
then when you do here -2, you will get 12 by 2, which is equal to 6, which is a whole number or an integer. So you will say, okay, fine. I'm not getting something in the, so this way. But here what happens when you do in the beginning, Swapnil, you can try with both the numbers, but it will take a lot of time. So once you start practicing, you will get to know, okay, 3 will not come and 2 will come.
Yeah.
So this way you can take out. There's always the way, but this will be time consuming. That's all.
Yeah.
Okay. So now you know you can assume, not a problem.
Yeah.
You can try also. But what you will see somewhere something. See here to oxy. Sometimes if suppose number also comes, suppose 11 comes, then also here it won't be balanced. Like after the reduction and oxidation, it won't be balanced. So that also happens. So from there you come to know, okay, the equation is not balanced. That means I've thought something wrong. I've done something wrong.
Right. So if it equals to 11, the equation is not balanced.
Yes. So suppose it comes a whole number, say 5. Say X comes out. We are thinking, ki, okay, chalo, chromium comes out to be 5.
Yeah.
Okay. Let's think it that way. Let's take it, ki, okay, chromium came 5. So let us start assuming. Okay. So you said, okay, I have taken and I have taken +3 here. I have taken +3 here, and with this +3, suppose I got chromium as 5. Correct. So you will say, okay, chromium is decreasing, oxidation number is decreasing. So when oxidation number decreases, what happens?
Just reduction.
Yes. So here reduction is taking place. Okay, good. You will say, okay, this will be 2 because here it is already 3. So from 3 to 2, again, what is happening? Oxidation number is
decreasing.
Again, reduction. Can it happen in a chemical reaction?
No.
No. One has to be oxidation, one has to be reduction. Second, if you see on the right hand side, what are the charges? 3 plus 2, 5. On the left hand side, what are the charges? 5 minus 2 plus 3. Okay, 5 minus 2 plus 3. So 8 minus 2, which is 6. So 6 and 5 are not equal. That means your you were asking, no, how do you check are they balanced? This charge, the final charge after doing, this should come equal. Here, if it is 6 and 5, no. You will get 0. The chemical reaction is not balanced. So these are the signs. See, two things, 2 times reduction will not happen. Secondly, the LHS and RHS charges are not equal. And that is the reason now we have to take 2, then only this equation will be a complete redox reaction. Correct?
Yeah.
Clear?
Yeah.
Are you sure? Okay. So I'll write it more neatly for you once again. So this is Cr2O7 plus Fe will give you Cr plus Fe. Here I'm going to take the charge as plus 6 minus 2 plus 2 plus 3 plus 3. So here from 6 to 3, oxidation number decreases. That means it is a reduction. Oxidation number increases. It is oxidation. That means it is a redox reaction. The charges on LHS plus 6 minus 2 plus 2, 6. On the right hand side, charges are plus 3, which is equal to 6. Why am I cutting? I mean plus 3, 6. So LHS equal to RHS. Hence, our balancing or the charging or our redox reaction is done perfect. Okay?
Yeah.
Yes?
Yeah.
Let's try one more. And I'll not teach you more than that. Today you try to understand this concept. Okay?
Yeah.
Practice on this.
Yeah.
Okay. Only one more question we will do. Okay? Zn plus HCl will give you ZnCl2 plus H2. Can you tell me where is oxidation happening? Where is reduction happening?
Okay.
Acha, wait. Tell me the charge, the ones which you know first. Let's start from your end. Okay. Do you know charge on zinc?
No.
No. Leave it. Okay. HCl, do you know?
Yeah. Yeah.
Yeah. Hydrogen is?
+1.
Chlorine is?
-1.
Okay. Can you tell me the charge here on ZnCl2? Can we find it out? See,
Yeah.
ZnCl2, you said this I don't know. Correct? This you know. So what can I write? X minus 2 equal to 0. So X equal to 2. So here you know the charge. Correct? This is +2 and this is -1. Correct?
Yeah. Yeah.
So what do you see? What do you see? That chlorine remains same. The charge remains the same on chlorine.
Yeah.
So whatever is happening with zinc and hydrogen. Correct?
Yeah.
So when you have seen that zinc is +2 here, what will happen? We will write 0 here.
Why?
I will come to it.
Okay.
And here I will write 0. Why? Because if you observe carefully, very carefully, what do you see? H2 is in which state? When you write H and when you write H2.
It's complete.
Yes, because H plus H, 2H. That is why it is in the elemental form. Correct?
Yeah.
Same way, zinc also, when you write it like this, it is in which form?
Elemental
form.
Okay.
And that is the reason I will say zinc.
Yeah.
The oxidation state is
Increasing.
That means it is the
Oxidizing.
correct.
Oxidation. Right, but the equations aren't balanced. So it doesn't have to be balanced.
Hydrogen is
decreasing.
I mean, the oxidation state is decreasing, so it is called a
reduction.
Let's balance it. Okay.
Oh, so we balance it afterwards.
So it is 0, +1, -1.
0.
Okay. So this becomes 0.
0.
And on the RHS, what happened? +2, -1, +0. So it is +1. That means
it is unbalanced.
It is unbalanced. So now it is not unbalanced by charge. It is unbalanced by molecular structure. Why? Because chlorine is 2 and here chlorine is 1. H is 2, here H is 1. So you will write 2 here.
What does that
Now if you balance, now it will be done better.
Right. What does that do?
What does that do? That will make a huge difference. Zn will remain 0. 2 into H1, that will become 2. And chlorine will be -1 only.
Why?
So 2 minus 1 will be 1.
Why?
Okay, so where have we added 2?
Why does only hydrogen increase?
Yes, we've added before hydrogen, correct. See, here you are not increasing the charge. Charge is this only for chlorine, only for hydrogen. But molecular wise, here it is chlorine 2 and here it is chlorine single.
Yeah.
That is the reason that it has to be balanced molecular way also. Correct?
Yeah, but why does only hydrogen increase?
Because you have written for charge you have to take into consideration where you have applied this. Correct? And when you are taking I mean the molecular one, you have to take the whole this thing. That's the basic difference you will get to know, and that's why redox is difficult.
Okay.
So Swapnil, right now I know it is tough. First time students feel it is really tough. Just try to check, listen, understand, check once again, and we'll take it forward from here. We have to do many tough questions like this.
Yeah.
Okay? So don't worry. Alright? Thank you. Please like, subscribe and share my channel.